Welcome to Discovering. Tonight, we are on board the Kiyi, a 107-foot research vessel, while the crew does their offshore deep water fish surveys on Lake Superior.
By sampling every year these same stations, we can index if those populations are static, increasing, or decreasing.
So sit back and relax. It's Monday night, and it's time for Discovering.
The secret streams that flow beneath the cliffs of colored stone, forests thick and healthy with birch and pine and oak, surrounded by the greatest lakes this world has ever known. The black bear's awesome presence as he roams the hills and fields, call of the timber wolf, the loon's lonesome trill, the eagle soaring high above, the trout lies deep and still. These are what I treasure, the only way I measure feelings that I have for this fine land. There is so much to discover when you're a long-time lover of northern Michigan.
Many agencies survey the fish populations of Lake Superior, but most of the data comes from the U.S. Geological Survey Great Lakes Science Center and a team of research scientists who spend weeks circumnavigating the lake to collect samples and data to determine the status and trends on the entire fish population of Lake Superior.
Today is the first day of our what we call our offshore fish community survey. We survey the lake on an annual basis. We have two main surveys. One's of nearshore waters, which we do normally between mid-May and mid-June. And then the offshore survey we do during the month of July. And this is a survey that we began in 2011 and has been done every year, minus a couple years where the pandemic.
This data goes to the various state DNR, universities, tribes, and other agencies who manage and study the fish populations.
So they all sort of covet the information that we are providing about the dynamics of the fish populations, their trends, and also the recruitment levels. So we're collecting data because USGS has no authority to manage fisheries, but we're collecting it for our partners that do set harvest quotas for fish in the commercial fisheries and in the recreational fisheries. So we are an agency that collects information but doesn't manage fish populations. We can provide, with our infrastructure, this ship, our trawls, the best information that can be obtained about the fish populations, free of any inherent chance of bias, because we have no skin in the game when it comes to managing the fish populations, right? We are here to observe and report, and that's what we do.
The published reports are also available for the public to view. This information can help anglers to better understand what to expect from the lake. Are there more or less fish on a given year? For example, Dan is excited about this year's spring nearshore survey, which shows the lake is chock full of all fish species, especially age 1 cisco, also known as herring, which commercial fishermen will benefit from in a few years. Looking back 10 years ago at the 2013 survey, there was almost zero cisco recruitment.
We sampled the nearshore zone during the month of June. We documented really large catches of age 1 ciscos, which is a cousin of Kiyi, and age 1 bloaters. In fact, the catches were so large that they exceeded any other year in our time series. The nearshore cruise has been undertaken longer, since 1978, and we had record catches in 2023 of fish that recruited this year that were hatched in 2022. To put that in perspective, it's the record for levels of baby herring and baby bloater in Lake Superior in over the last 45 years. The lake is chock full of baby native fish right now.
was fortunate to join the crew as they sailed from Ashland, Wisconsin to Ontonagon, Michigan at the start of their offshore survey in July. Also on board are scientists Mark Vinson, Sydney Phillips, intern Yana, Captain Joe Walters, First Mate Terry Luchanen, and Jim Boyd, who is serving as ship engineer. They have 35 sites lake-wide to survey, most at depths over 300 feet. Today, we're traveling 100 miles and surveying 2 sites.
Well, the Deepwater survey is targeting the Deepwater sculpin, the Kiyi, and the deepwater form of lake trout called the Siskiyou or fat lake trout. They'll represent about 99.9% of the total biomass. There are species of fish, mainly the Kiyi and the deepwater sculpins, which are very important to the ecosystem offshore. So it's important for us to monitor the status and trends of those populations, to know if they're increasing or decreasing, and to try to come up with understanding of why those trends may be occurring. They are important, those 2 species, as prey for native lake trout in Lake Superior. So it's in part a survey to understand levels of prey fish, and also a survey to understand the status and trends of these endemic or native species. Another thing that we're capturing on this survey is any recruitment events, particularly of Kiyi. Recruitment is defined as a fish that survives to age 1. There's a very high mortality of larval fish, age 0 fish, in their lives. In fact, most of fish never make it to age 1. But if you can survive to age 1, you have very predictable survival rates throughout the rest of your life. So that is why we call that age a recruit. It will, if it survives stage 1, it will recruit and then eventually survive to adulthood at very predictable rates. Not all of them will survive, but yet at very predictable rates.
As you've probably noticed, the name of the ship is the Kiyi, named after the fish Dan has mentioned, the Kiyi. And I'm excited to see this native fish that very few people in the world get to see. Pretty much just this crew are the only ones to ever see or touch this rare fish.
The Kiyi is only present in the world in Lake Superior currently. There were populations of Kiyi in the other Great Lakes, but through alteration of habitat and the introduction of invasive species, those populations have disappeared, making the Kiyi in Lake Superior especially important because it's the only place on Earth where this species is fawned. Kiyi are a deep water species that occupy depths greater than 300 feet. So fortunately for Kiyi, there's a very large amount of habitat in Lake Superior. About 80% of Lake Superior is at a depth greater than 300 feet.
We had 3 to 4 hours before we arrived at our first survey site. Lake Superior is a pretty big lake, so I took this opportunity to chat with the captain of the Kiyi.
My name is Joe Walters. I'm the captain of the research vessel Kiyi. Kiyi is 107 feet long. It's an Atlantic-style trawler. It was built in Pensacola, Florida at Patty Shipyard. We work primarily on Lake Superior. We have a vessel on each lake, so we're stationed in Lake Superior. She's twin screw, total horsepower about 1,250 horsepower. Travels about 12 miles an hour normally. When we're doing our trawls, we're running at 2.5 miles an hour. And these are bottom trawls that we're doing today, so we'll be actually putting the net all the way down on the bottom. And the deepest one we will get to on this trip will be about 1,100 feet. We have a lot of equipment up here. We've got navigation equipment. It's all GPS based, of course. We have chart plotting equipment. We have radars. We have radios for communication. We've got internet. We've got weather information. We've got quite a lot of instruments that tells us all kinds of things. This is the chart plotter I'm using here. This is our position here, the red circle, and we're headed up here to this transect here. We're always monitoring weather. Weather can be an issue. It starts getting a little bit too rough. It starts becoming unsafe for us to work, and then we'll cease operations and probably go into port somewhere and wait it out. Or if we're supposed to get underway one day and it's already blowing, we'll just wait. So there's no point in trying to work when it's in that kind of conditions because it's just too dangerous, and actually the data that we would get wouldn't be all that good.
Thankfully, today is a beautiful day on our favorite inland sea. Before arriving at our first survey site, the crew set the deck, preparing the bottom trawl net and doors to be dropped into the lake once we hit the site coordinates. Larval drift nets were also put in place. And then once we hit the survey coordinates, the team dropped the net.
Trawl is first deployed off the back of the boat over the net reel. Metal chains that are attached to the doors that we connect to what's called the bridle of the trawl. So what happens is the net reel initially is holding the weight of the trawl, but eventually it's transferred to the trawl doors, which are connected to winches that are on top of the back deck there. And it's those winches that are used to lower the trawl door. The trawl doors are doing two things. They're taking the trawl to the bottom, and they're also, when the boat is going forward, spreading out with forces on them and pulling the net taut so that it's fishing taut on the bottom behind us. The net itself is about 6 feet high, and when it's fishing, it's about 30 feet wide, or thereabouts. And it's fishing on the bottom. We know that it's on the bottom because we have sensors on the net that tell us when it comes in contact with the bottom. And so when we put it on contact, we have a mark time and we record the latitude and longitude, or the position.
Once the trawl is down, the team monitors the trawl as it sweeps the floor of Lake Superior.
We fish the same place every year, and so the net should fish the same at that place every year. We can fish differently at different places.
And then the trawl is brought back to the surface with the day's catch.
We pull it for 20 minutes, and then we use the winches again to lift the trawl, again recording the latitude and longitude so we know the distance the trawl was on bottom. If we know the distance it's on bottom times the average width of the trawl, we can calculate the area that was swept of the bottom. So then when we count the fish that are caught in the catch, we can convert that to fish per area. And our unit of measure is fish per hectare. And a hectare is about, well, it's 100 meters by 100 meters square, so like a football field long by a football field wide. How do we do? Here we have a native lake trout. It's called a siskowet, or some people sometimes call it a fat lake trout. It's the predominant form of lake trout in the deeper offshore waters of Lake Superior. We can tell it's siskowet because its eyes are really set on the very top of its head.
Once the fish hit the table, the first thing the team does is sort the catch to species.
Some of them are blue, the pretty ones. All the pretty sculptures look like this.
It's a typical catch, what we come to expect offshore with the species composition, but what's really different about this year is this high numbers of these what are now age ones, deep water ciscos, we think are Kiyi, that hatched well in 2022 and survived well. So this is an exceptional number for us to catch compared to recent years. Yeah, this year I identified it as age 1 Kiyi, would have hatched June or July of last year. So it's just over a year old, maybe 13 months. And I can tell that it's a Kiyi by how long its paired fins are. These paired fins here extend almost all the way to the vent of the fish, making it a high candidate to be a Kiyi. Also, even at an early age, it has a very large eye relative to its head size, which is an adaptation for acquiring light in dark places at low light levels. These fish that kind of look like dinosaurs, to me, what we call deep water sculpins. They're native to the Great Lakes. We have one of the strongest populations of deep water sculpins in the Great Lakes in Lake Superior. Really important food for the Siskiyou lake trout, especially the juveniles in the offshore zone. They sort of start eating fish, they'll start to eat these guys. So now we've sorted the catch, and Mark has been on the side recording the weights of that catch. So it's time now to start recording numbers. Okay, we're going to start with deep water sculpin lengths. 83,
90,
90,
65,
65,
85,
85,
91.
91. It's a good sample for being able to reconstruct what the size distribution was at the site. And when you consider that we're doing 50 at 30 sites, we'll have a really full picture of what the population size structure looked like.
That's about as big as they get, 10 inches.
After they sorted the catch and weighed and measured them, things got a little messy as they collected samples from the fish. Just warning you, in case fish blood and guts aren't your thing, but necessary in the name of scientific research to better understand our fish populations.
We're going to take a subsample of these fish and we'll do a couple things. We'll collect a fin clip that we can use to run through our genetics lab, which has a way of identifying the fish from its genetic code. So that will confirm our field identifications.
Because of the library of genetic samples the USGS has created, they can even determine the species of these small larvae that were captured in the drift nets. This genetic sampling is a game changer for the agency, reducing any field identification error and reducing the amount of DNA samples they will need to collect in the future.
Now, it took us 2 or 3 years to get the adult library built so that we could start having a basis by which to compare the genetic samples from the larvae and the juveniles to the adults. 3 years, and we've already learned so much from the genetic assignments. It's like a very exciting time to be able to understand the fish in a way where we're not making any guesses about their species identifications. We're freeing up any uncertainty that we used to have about what we were looking at. And it's hard because they're so small, right? Especially when they're larvae. So we're learning so much about when the different species of crignines hatch, how they grow based on these data, how they survive. Like now we're learning about what they eat as well, and if there's differences between the species. It's really cool, like a renaissance for new knowledge.
Stomach samples were also collected from the age 1 Kiyi.
We're also starting a new study to look at the diets of these juvenile Kiyi, so we'll be collecting up to 25 stomachs of fish from this site for further analysis of their diets.
Immature female.
The sex of the Siskiyou lake trout and adult Kiyi were recorded, and scales and the otoliths from each were collected for lab work.
There is no such thing.
These are ear bones. They're called sagittal otoliths. Otoliths for short. And they get sectioned with a little tiny diamond saw. And then you can count rings on them just like a tree and find out how old they are. You can age them off scales too, but they're not as accurate as the otolith. But you can take that scum that's on there and you can run chemical analysis of those after it's dried. So like we've run projects with chemical analysis of scales that are 70 years old.
What can they get from those old scales, Mark?
You could do genetics on it. And what they've done with Siskiyouettes with genetics is to look at integration to how much inter subspecies marriage has been going on between fats and leans.
All this new research is exciting.
We rediscovered one that we thought was extirpated. It was actually in the lake, called short-nosed cisco.
After a full day on the water, we arrived safely in the Ontonagon harbor. The next morning, the crew set sail to continue the same process on 30 more sites. That's all for tonight, and I hope to see you right back here next week for Upper Michigan's very own Discovering.